Hello friends, I hope you can see my screen. So today we are going to take one more machine learning algorithm which is Bayes Classifier. You can see here which is under supervised learning module. So we are going to see the detail of this particular classification algorithm. All right. So before going deep dive into the topics, let's quickly go through what topics we are going to cover in this session. The very first topic was where we are. So right now I have showed you here we are, and then the topic two like use case and problem that NAB-based classifier can solve, like real-time prediction, multi-class prediction, text classification, spam filtering, sentiment analysis, recommendation system, and there are a lot many use cases of this particular classifier. So we will be, when we are looking into the mathematics, so we will see these two examples. All right, we will basically focus on this one, and we believe that we can apply the same logic for this kind of use case. All right, so topic 3, we will see some terminologies like what is Bayes theorem, posterior probability, class prior probability, predictor prior probability, evidence, likelihood, and these are different types of Bayes classifier based on static distribution. So we will see those things later. All right, and we will see some Python library like Gaussian MB, multinomial MB. These are the reference link. You can see the detail of this classifier, and the method parameters, the tuning parameters for this classifier in this particular library. There's good documentation. When you will go through it, you will get to know what each parameter signifies. All right, so we will see then the most important thing, that is the math behind Bayes classifier, or how does Bayes classifier work. All right, there are some assumptions. We will see that. And once you saw this video, I will recommend you to go through these links, any of them or all of them, so you will be more confident what you have learned and what you have seen. All right, while going through this document, it will be super fast because you have seen this video and I have explained the mathematics, how things works actually. All right, then the topic 6 is advantage, topic 7 is disadvantage, 8 is tips to improve the power of NAB-based model, and 9 you can do Python or R coding with and without using libraries. So this will give you better understanding of this particular classifier. And the topic 10 is open question and some conclusions to draw. So these many topics we are going to cover, although I have written the most possible and detailed topics of this particular classifier. I am not going to cover all of them. Okay, my main focus is the math behind this particular algorithm, machine learning algorithm. Rest you can refer Google and some recommended link, and you can practice on your own to get a handful experience of this particular classifier. All right, so let's quickly dive into this, the mathematics behind Bayes classifier. All right, so let me close this first. Now, so this particular classifier is based on Bayes theorem. We all are familiar with Bayes theorem, what it is, and you can see there are 4 quadrants. This is, let's say this is first quadrant, this is second quadrant, this is third, and this is fourth. So there are different way to explain Bayes theorem. We like here A is an event, B is another event, so we can say a probability of A given that B has occurred, a posterior probability, and probability of B given that A has occurred, some different name P of A, some different buzzword or technical jargons, since we are dealing with some kind of algorithm or some kind of classifier. For the time being, I believe that I am doing raw mathematics. I don't know these terms like posterior, evidence, likelihood, prior probability, and other words, other technical jargon. So I am only concentrating and focusing on first quadrant, that is probability of A given that B has occurred is given by probability of B given that A has occurred into probability of A by probability of B, and we are going to use this formula frequently. All right, so let's take an example. Here we have one data set which has 30 rows, and it is taken by some of the retail company called, let's say, Amazon or Flipkart or Spencer or Reliance Fresh. So what they did, they have they have maintained one Excel sheet for 30 different days, and that they have some descriptive features and they have some target features. So the descriptive feature was like day, whether that day is weekday or holiday or weekend, whether they are providing discount on that day or not, and whether there is free delivery or not on that day. And based on three descriptive features, they is deciding that okay, what is the condition of purchase, whether there is purchase or there is no purchase. This is the two categorical values of this target feature. So they did this for 30 days. So they have 30 rows, 30 samples, 30 observations. All right, so we have this data set here. Although I am not showing the 30 days, only the 15 days, since it's an image, so 30 days data is on. But yeah, we believe that we have entries for 30 days. All right, now there is another thing which I want to point it here is that in NAB based classifier heavily use Bayes theorem, and these descriptive features which is contributing in taking the decision for a target feature. So what we are saying, what we are assuming here, these three descriptive features are independent of each other. This is our first assumption, and the second assumption is that in taking the decision about the target feature, these all features are equally important. They are not biased actually. All right, so they have equal contribution to the decision of taking about the target features. So this is the second assumption. So independent features and equal contributions are the two assumptions of Bayes classifier while dealing with the Bayes theorem. So please keep this in mind. We will reiterate this later. Now, since we are going to do some sort of calculation or computation on this data set, so we need to convert this into another table so that we can frequently refer those numbers and apply Bayes theorem quite easily, because we don't know how many times we are going to apply Bayes theorem in this particular problem. All right, so we are going to do that. So for that purpose, we are converting this data set into frequency table and then likelihood tables. Okay, so let's understand frequency table first. So we have three frequency table here. Why it is three? Because we have three descriptive features here: day, discount, free delivery. So day, discount, free delivery. So we have three frequency table, and each descriptive feature has some contribution to target features. So target feature goes here. So in all the three frequency tables, we have target feature. So this is one-to-one mapping, one descriptive feature and one target feature mapping. All right, and we are filling entries. So what these entries are, or what these values are. So let's say I am seeing or considering this frequency table for the time being. So this is day descriptive feature. I will go to the day descriptive feature, which is here. All right, it has three categorical values like weekday, holiday, and weekend. So weekday, weekend, and holiday. And target feature has two categorical value. So it is yes and no. Simple. Now, out of 30 observations or 30 samples, how many days are weekdays? So we will find that there are 11 weekdays. So 9 plus 2 is 11 weekdays. So this is 11 weekdays. How many days are weekends? So 7 plus 1, 8. There is 8 weekends. Out of 30 observations, how many days are holidays? So 11 are holidays. And similarly, on how many out of 30 days, how many days there is purchase. So if I add up this 9 plus 7 plus 6, 9 plus 7 is equal to 16 plus 8 is 24. So there are 24 days on which there is purchases, yes. And how many days where there is no purchase? So 3 plus 2 plus 1 is 6. There are 6 days there is no purchase. Now what this 9 is, so this is something, this frequency written under white cells are something conditional, like that the how we will reiterate what is the frequency or what is the count of days or observation where the day is weekday and we have purchase is 9. Similarly, what is the frequency or what is the number of observations out of 30 those observations in the data set where the weekend is the day is weekend and there is purchase, it is 7. So out of similarly, out of 30 observations, what is the frequency or number of observations where the day is holiday and there is purchase? So it is 8. Okay, so you can see here, like the day is weekday and there is purchase, yes. So this is 1 weekday purchase, yes. So the frequency is 2. Weekday, no, I will not count it. Weekday, yes, the frequency is the count is 3. So likewise I have counted it and I have added. So when I add this up all, like 9 plus 7 plus 8 plus 2 plus 1 plus 3, so there will be 30 observations. So this is 30 observation. Similarly, I have filled I have prepared this frequency table for free delivery descriptive feature and frequency table for discount descriptive features. All right, I hope you have understood how to prepare frequency table. If not, please pause the video and ponder for a while. Okay, how this is prepared from data set, how a frequency table is being prepared from a data set to frequency table. So that is one thing. Now if you have understood how frequency table is being designed, now we should understand how likelihood table is being prepared from frequency table. So you can see here, this is the white cells, this is the white cell, this is conditional, this is sort of conditional, it looks conditional to us, and the blue cells are unconditional thing. So, and these entries are not frequencies, these are probability. So sorry, excuse me. So what this 9 by 24 signifies? So this is probability of the day that it is weekday and there is purchase. So it is 9 by 24. All right, 9 by 24. So why this 24? Anyone else can say? So out of 30, there are 24 days where there is purchase, so it is 9 by 24. And this 7, this is the frequency, this is the count of the event or observations where the day is weekend and there is buy, so this 7 is the count. And why this is 24? So divided by, yeah, there is purchase, so 7 by 24. So this makes conditional probability, that the probability that the day is weekend and there is purchase, so this is 7 by 24. What is this holiday? This 8 by 24. So this is the number of observations where the day is holiday and there is purchase, so this is 8 divided by 24. This is out of 30, there are on 24 days we are purchasing, so this 8 by 20 is the conditional probability that the day is holiday and there is purchase, so this is 8 by 24. Similarly, for no one, we have filled the entries. And this blue cells is what? So out of 30 observations, there are 24 days there is purchase, so this 24 by 30 is the unconditional property actually. Okay, this is the probability of purchase is equal to yes, this is the probability of purchase is equal to no out of those 30 days. What is this 11 by 30? So this is the probability of weekdays. We have 9 plus 2, 11, so we have total 11 weekdays in that 30 day observations. We have total of 8 weekends in that 30 day observations. We have total of 11 holidays in that 30 days observation, so this is 11 by 30. So this blue cell is unconditional probability and this is conditional probability. Similarly, we fill the data for discount descriptive features and free delivery descriptive features. I hope you have understood the likelihood table as well. If not, pause and ponder for a while to understand likelihood tables, frequency table, and data set, because this is very important. We can't directly do mathematics. We can, but we choose to first prepare frequency table and likelihood tables before applying or directly applying Bayes theorem on data set. All right, because we should have numbers and frequencies. All right, so since we are dealing with descriptive features, so we are getting such kind of numbers. If it is a continuous descriptive features, so we can apply different probability distribution functions like Gaussian distribution functions or normal distribution functions or Bernoulli distribution functions. There are so many distribution functions. So to calculate the probability, we can, instead of counting observations, dividing number by number, we can do some integration. We can perform some integration or blah blah blah, lot many things depending upon distribution functions we have chose. All right, so I am not complicating. Just take the simple example, and our purpose is to just understand the mathematics behind Naive Gaussian black classifier algorithm. All right, so we are not complicating ourselves with distribution functions and calculations involving integration or other stuffs. So we are dealing with numbers. All right, now let's do one thing. Let's understand this. Sorry. So let's a future day come for those Facebook or for those retail companies like Spencer. So on that day, the day is holiday and the discount is yes, and they are providing free delivery. All right, and they want to calculate probability. They want to see that they want to classify that day, whether it's the day is purchasing day or not purchasing day. All right, so what this problem is, let me convert this problem to mathematical calculation. That is, let's say the event A is no buy and the event B is this one. Since these three descriptive features or conditions are mutually independent of each other, so we know that probability of A intersection B intersection C is probability of A into probability of B into probability of C from our probability classes if A, B, C are independent. All right, so Bayes classifier assumes that the descriptive features are independent of each other and they equally contribute in taking decision about target feature. All right, so based on that we are doing some calculations. So we know that from raw mathematics, probability of conditional probability of A given that B has occurred is given by P of A into P of B given that A has occurred divided by P of B. Now if I put this long statements, what P signifies and what A signifies, so it will look like this. And if I fill the entire entries, so it will look like this one. Why this multiplication of three probabilities? Because they are independent of each other. Otherwise they could have one probability multiplied by probability of no buy, but they are directly, one step is skipped here, so they are directly written because they are independent of each other. So their individual probability is being multiplied. Now what we can do, we can see here probability of discount is equal to yes and there is no purchase. So probability of discount is yes and there is no purchase is 1 by 6. So this white cell, it will go to 1 by 6. Probability of free delivery is equal to yes and there is no purchase. So probability of free delivery where there is yes and where there is no purchase, this is 2 by 6. So this will go to here. Probability of day is equal to holiday, day is equal to holiday and there is no purchase, it is given by 3 by 6. So it will go here. Probability of no buy, so probability of no buy is 6 by 30. It is same across all the likelihood tables. So this is 6 by 30. Again probability of discount is equal to yes. So out of 30 days we have given discount on 20 days, so 20 by 30 makes to here. Probability of free delivery is equal to yes, so probability of free delivery is equal to yes. So out of 30 days, on 23 days we have given free delivery, so this is 23 by 30. This is unconditional probability, so it will make 2 here. This is 23 by 30 and probability of day is equal to holiday, so probability of day is equal to holiday, so it is 11 by 30. It will make here. So we did this calculation and we get 0.178. such a low probability of no purchase based given that this is the condition on descriptive features. So, and this makes sense why people will not purchase if such things are given to them. Okay, so this is very interesting. I hope you have understood these calculations, and I hope you understood the significance of likelihood as well as frequency table, why we have converted data set into frequency table and then likelihood table. Why didn't we go for direct calculation from data set to this? Because this is quite tedious, counting and all those stuffs. So this is one thing. Now let's calculate what is the probability of buy if the same condition is given for that day. What is going to happen? All right. So this is again, I changed the event A from no buy to buy and put this value, and I did this calculation like probability of discount when is equal to yes when and there is a buy. So probability of discount is equal to yes and then there is a buy is 9 by 24. Probability of delivery is equal to yes and there is buy, so it is 21 by 24, and likewise I have filled the data and you see it is 0.9. It's quite a high probability. Okay, so this makes sense, the prediction looks good. So probability of buy, this is greater than this. So for this descriptive feature, how will we classify the target feature? So yes, there is a purchase. So the row number 16, this is the training data set, and the 16, the testing data set we were testing it. Our model says that okay, for this thing there will be purchase on that day. So the 16th entry will be yes. All right, and this dataset table will keep growing. Mind it, one of the advantages of Bayes classifier is that it works so well for less amount of data and even less number of columns or descriptive features. All right, but once you change your data set, these all frequencies and calculation will change. All right, so we can keep track of our model and its accuracy. All right, okay, why I include this, there are several aspects of this one. We will see those thing in disadvantage and disadvantage, and there were several topics I have made at the bottom of our session. So we will see some rules or some guidelines or some takeaway points to perfectly or twin our NABS model. All right, so this is cool. I believe that you have understood this particular example. All right, now let me take another data set which is so frequently used. So this is another data set. This is 14 rows sample data set where there are 4 descriptive feature and the target feature is play golf. Like on a day we are capturing outlook, temperature, humidity and wind situation on that day, and we are observing on 14 days, and some person played or not on that day. So this is some historical or past data set which is maintained by some guy, some club, some sporting club, and in future there will be some day and there will be some climatic condition on there. So based on that climatic condition on that day, we want to decide whether a person is going, where athlete is going to play or not. So this is it. Now from this data set we know we first convert this data set into frequency table and then likelihood table, and then we go for computation, apply Bayes theorem. All right, and at last we take decision about okay what class it belongs to. So you see it is same, it looks different, but yeah, it is same. Here the frequency table and the likelihood table both are merged, and this descriptive feature outlook, this is not written here, it is at the top of this table, and these are the frequency table and this is the likelihood tables for this one. Similarly for temperature descriptive feature, this is the frequency table and this is the likelihood table. Similarly for humidity, this is the frequency table and this is the likelihood table. Similarly for wind situation, descriptive feature, this is the frequency table, and this is the likelihood table. And for target feature, which we were writing in blue, unconditional probability, so this is the frequency table and this is the target feature. So this is the likelihood table for target feature. So there are several ways to represent frequency table and likelihood table. So this is just another way, and we can, we can do a mathematics like, okay, in future, or we trained our model using this 14 data set. Now we want to predict one future day based on some climatic conditions, whether athlete is going to play or not on that day golf. So we did this stuff. This is just a simple Bayes theorem and we applied it, and you see here probability of playing not golf based on this condition, today condition, is this one, and probability of playing golf based on this condition is this one. All right, so since the probability of this is greater than probability of no, so this particular data set we will categorize it into yes, play golf yes on that day. All right, so this is cool stuff. You can pause the video for a while and just double check you have understood this data set, this frequency table, this likelihood table of all the examples I have demonstrated here. All right. All right. Now, let me move to this slide. So this is Geek for Geek site, where they explain Bayes classifier. So they have taken this data set, play goal for nos. I also referred this one, and just go through it line by line. You will get to know what they are trying to say. I am saying feature, descriptive feature, and columns or predictors. They are saying feature matrix. They are saying target feature as a response vector, and lot many technical jargons they are using. So they all are synonymous. So be very much mindful while dealing with data set. What are the synonymous technical jargons? Which technical jargons are used in place of which? So don't make yourself complex or puzzled with the technical jargons. Use anyone and you can go ahead. Now, and the Egyptian in doing Bayes calculation is that the descriptive feature is independent and the target and the descriptive features are equally contributing to the outcome, target features. All right, and yeah, again go through these paragraphs, you will understand what they are trying to say. Now the Bayes theorem they are talking. Okay, so Bayes theorem, someone is saying evidence, posterior probability, prior probability, lot of blah 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 blah, many technical. Okay, I will show that part. I will not skip that in this video. Okay, now again they made some tables. These tables I have shown you, frequency table and likelihood table all together, and they did some calculations and they classified a future training testing data set. All right, why Gaussian nab? So obviously, okay, let me show another thing. So there are 5 Bayes classifier based on probability distribution function. So this is Gaussian Bayes, multinomial Bayes, complement Bayes, Bernoulli Bayes, categorical Bayes. So these many Bayes distributions of functions are there. Since we are dealing with categorical data set, so we were calculating frequency and we are dividing our numerator as number and denominator as number, so number by number, and those numbers are frequency. All right, because we are dealing with categorical data set. But once it is a continuous data set or some sort of different data set, okay, so we will go for Gaussian distribution functions or probability distribution functions for probability calculations, and then we will apply the Bayes theorem. All right, so this scikit-learn website has a very good documentation about different probability distribution functions and Bayes application, so you can look into this. Our purpose of this video is to understand the mathematics behind Gaussian Bayes classification, not understanding the probability distribution function and how to consume them in Bayes theorem. All right, so this is a very good documentation about different NAB based on distribution functions. All right, so this is the class, this is the color class classifier, these all are the packages. No need to write the code for this one. Okay, just you need to understand different libraries and all those stuffs. Like when I click Gaussian NB, so I am going inside this one. All right, and I am saying, okay, what this particular class Gaussian NB contains what parameters and how to doing this thing. Okay, so there are several use cases of this one, so this is not a big deal to understand. All right, now let me go back to, so this was geek for geek, advantage disadvantage they have talked. I'm not going through paragraph or line of this websites, these blogs. Let me go another very cool thing. So this is DataCamp blog about NAB-based classification. This was pretty cool stuff. I went through it and I understand so well about NAB-based classifier. So I think this will be very useful for you guys as well. You can go through it. I have shared the link. Or I have displayed the link in the videos as well. So they are using some training data set and they have trained the model, and they use test data set to predict the model, and they are just checking the model accuracy and precision and recall. And yeah, you can see here again the probability of Bayes theorem basically. So S represent for hypothesis, D represent for data. So there are several ways of dictating Bayes theorem. Okay, and they have shown this frequency table, likelihood table, and the mathematical calculations are there. So it's very good stuff. When you go through line by line, you will understand each and everything about NAB-based classifier, how it works and all those stuff. Okay, this is Python code. So they are using some scikit library encoding feature, and then combining this, generating model, and sorry. So this is cool actually. You can go through it. Model generation and evaluating model. So there are some advantages and disadvantages of NAB-based. So you can go through this blog and you will understand what are the advantages, what are the disadvantages of NAB-based classifier. I am not diving or deep into these topics. Why? Because it is useless to reiterating those things. There are several materials on Google. You can refer and you can understand those things. My only purpose was to clarify the mathematics behind it, so that we can pretty fast while going through these blocks. All right. Okay. Now let me just highlight this thing because I have shown this. So what is this posterior probability, what is this predictor probability, what is this class? So remember, this is the probability of no purchase the target feature. So this is prior, because we have 30 data set, and out of which the probability of there is no purchase is 6. So 6 by 30 is the prior probability of our class, of our target feature. Okay, if it is the purchase 24, if there is a purchase and its frequency is 24, so 24 by 30 is the prior probability of our target feature. And what is this posterior probability? So this is the future data, the testing data based on some conditional probability. So this is the posterior probability. So posterior probability signifies means probability of finding target feature, one of the value of target feature based on some future data. All right, this is predictor probability. So these all are independent descriptive features. They multiply each other, probability multiply with each other. So these are predictors prior probability. And this is likelihood, the white cells in the likelihood table. Okay, remember the likelihood table and the white cells were there, and there are frequency as well. So those frequencies are some conditional sort of things. So this is conditional one. So this is one thing. So in small state, what we can say, posterior is equal to prior into likelihood by evidence. So sometimes we say this thing as evidence as well. Okay, when we terms of hypothesis and those stuffs, this is our prior belief, and this can be Gaussian, This can be multinomial, this can be Bernoulli, and depending upon different probability distribution functions, obviously the way we are calculating the probability, sometimes this may involve complex integration, sometimes it's just a division numerator by numerator of numbers, division of numbers. So depending upon that, our Gaussian NAB based classifier type will be changed, so we will have different class. So this is it. So I hope you have understood NAB based classifier. Uh, if not, please go through these blogs. These blogs are very helpful. Uh, they have written the documentation in such a easy manner that just going through it, you will understand what Gaussian NAB based classification is. All right. Uh, Thank you, guys. I believe I made my point about NAB based classifier. We will see another classification machine learning algorithm in next session. Thank you.